Hi, welcome back to my channel. If you are new here, please consider subscribing my channel. And today, I would like to talk about 6G technology. 5G is not even live in most of the countries, but the researchers are already working on the next generation of wireless network. As studied, the Chinese Ministry of Science and Technology had started the fundamental works, and it is assumed that the speed goes up to 8,000 times higher than 5G. Besides, 6G can achieve stimulating speeds of around 1 terabyte per second. Dozens of researchers are on the job, but trust me, we are still years away from its deployment. Even the current 5G network we are beginning to use has been in the development since 2008. As 5G is closely associated with Internet of Things, the 6G era will probably grant us a whole new approach of connectivity. So, let's start. What is 6G? 6G, the sixth generation wireless network, is the replacement of 5G as it will be using higher frequencies and provide higher capacity and much lower latency. One of the goals of 6G is to support 1 microsecond latency communication, representing 1000 times faster than 1 millisecond throughput. The 6G technology market is presumed to ease large improvements in the areas of imaging, presence technology, and location awareness. Working together with AI, the computational infrastructure of 6G will be able to autonomously determine the best location for computing to occur, including the decisions about data storage, processing, and sharing. Advantages of 6G. Designed to support large number of connections greater than 5G capacity, which is about 10 times 105 per kilometer square. 6G transforms the healthcare sector by eliminating time and space barriers via remote surgery and guaranteed healthcare workflow optimization. 6G overcomes the generated indoors mobile traffic and the inefficient indoor coverage issues using femtocells or distributed antenna system. 6G uses terahertz frequencies, which has many advantages as like terahertz waves can easily absorb moisture in the air, hence it is useful for high-speed short-range wireless communication. Terahertz offers narrow beam and better directivity resulting into secure communication, which is achieved due to strong anti-interference capability. 6G wireless uses visible light communication which leverage benefits of LEDs such as illumination and high-speed data communication. Visible light communication does not produce electromagnetic radiation, hence it is not susceptible to external electromagnetic interference. Visible light communication also helps in building network security. 6G offers very high data rate, which is terabyte per second, and very low latency, which is sub-millisecond. 6G drawbacks. First, designing new network architecture. Second, 6G uses terahertz frequencies for part of its communication. Hence, drawbacks of terahertz can be considered as drawbacks of 6G. Terahertz signal is very sensitive to the shadows, which has great impact on the coverage. Moreover, lower frequency terahertz frequency incurs a larger free space fading. Ultra large scale antenna is a major challenge in terahertz, which requires high bandwidth and massive quantitative high resolution. Processing power is major challenge in designing low power and low cost 6G devices. Third drawbacks is 6G uses visible light frequencies for part of its communication. Hence, drawbacks of visual light communication can be considered as drawbacks of 6G as well. In order to manage a large number of terminals and networking equipments efficiently and less energy consuming, 6G system is a must. In order to fulfill this, network and terminal equipment circuitry and the communication protocol stack design is a challenge. When to expect 6G? 6G is to be launched commercially by 2030. 6G is being developed in response to the increasingly dispersed radio access network and the need to leverage the terahertz spectrum to maximize bandwidth and reduce latency. Although there have been some early discussions to identify 6G, research and development activities will continue earnestly in 2020. Many of the issues involved with implementing millimeter wave radio for 5G digital technology are supposed to be addressed in time for network operators to tackle the difficulties of 6G. What 6G will look like. 6G's wireless sensing solutions are expected to use different frequencies selectively to measure the absorption and adjust the frequencies accordingly. This is possible because atoms and molecules emit and absorb electromagnetic radiation at characteristic frequencies, and the frequencies of emission and absorption for any given substance are identical. 6G will have major implications in terms of public safety and critical asset protection for many government and industry solutions such as threat detection, health monitoring, feature and facial recognition, decision making in areas like law enforcement and social credit system, air quality measurements, gas and toxicity sensing. Do we even need 6G? Previous diverse technologies, including deep learning and big data analytics, will be integrated into 6G. 5G's introduction paves the way for much of that merging. Deploying edge computing is a significant stimulant for 6G to enable machine-to-machine connectivity within the Internet of Things, maintaining high efficiency and low latency for ultra-reliable, low-latency communication solution. In addition, a close link between potential 6G solution and high-performance computing has been established. Although some of the data from the Internet of Things platform can be managed using edge computing services, most of it would need more centralized high-performance computing services to process. Who is working on this currently? First, the University of Oulu in Finland is committed to a 6G research initiative referred to as 6 Genesis. The project will be conducted for the next 8 years and will develop a vision for 2037. Second, South Korea's Electronics and Telecommunication Research Institute is conducting research on terahertz band for 6G and envisions making it 100 times faster than 4G LTE networks and 5 times faster than 5G networks. Third, the Ministry of Industry and Information Technology in China is directly investing and monitoring the research and development process. Fourth, the United States is planning to open up 6G frequency for R&D purposes pending approval from the Federal Communication Commission for frequencies over 95 GHz to 3 terahertz.